In this video, we will talk about the two sample proportion z-test. So the first thing to know is if I want to know whether I should use this test or not, how do I know? Well, when you use this test is when you have a categorical variable of two levels with another categorical variable of two levels, okay? So for example, let's take gender and brushing your teeth. I'm just gonna write brush. So gender in this case will be males and females. So if you had other or maybe transgender or gender fluid, then you wouldn't be able to use this test because it requires two levels, and two levels basically you can think of two options. So if your variable has two options, okay, to choose from, then you're gonna be using this proportion, two sample proportion z-tests. Now you also have to compare it with another categorical variable that also has two levels. In this case, brushing your teeth is gonna be either a yes or a no. Okay, either you brush them or you don't. Here, that's I think the trickiest part to kind of know. Now, if you have more levels, you will use another test that I will talk about later on in another video. So the way that we kind of do that is you first have to set up, as usual, your null and your alternative hypothesis. Now, the way that we compare two different things is by giving them two different names. So one way to kind of do it is saying P1 and P2 are going to be two different proportions. That's why we have two sample proportions. So P1, because it's going to be the proportion of males who brush their teeth, and P2 is going to be the proportion of females who brush their teeth. So I set two different variables, whereas in the one proportion, you had only one sample. Here we have two different samples, one that belongs to the males and one that belongs to the females. Now, the way that we set up our null and alternative is using these two different things, P1 and P2. So to compare them, we would say that P1 is equal to P2. Remember, null hypothesis is always going to have an equal sign. So the null hypothesis basically is saying that the proportion of males who brush their teeth is equal to the proportion of females who brush their teeth. That means that they're both equally likely to brush their teeth. There really is no difference between genders and brushing their teeth. HA will say, no, I think that there's one in particular that doesn't brush them, okay? Then you would say P1 is not equal to P2. So you wouldn't set it equal to a number. You would just set them both equal to each other and then not equal to each other. Now, the way that Statcrunch does it is that it makes it a little confusing. It says that P1 minus P2 is equal to 0. And HA is that P1 minus P2 is not equal to 0. Now, these two actually are the same, but just Statcrunch tends to write it that way. And I'll explain why this actually might be a little bit more useful. So for your project, this is mainly what you're going to be writing, okay? The reason why these two are the same is that if I subtract that to the other side, you can get 0 on the other side. Because sometimes there might be some hypothesis tests where you think that the difference between the two proportions may be equal to some sort of number, okay? Or may exceed a number. So that's why this guy exists. But for your project, you can write this. Okay, this is okay. But just note that in Statcrunch, it'll want me to write it like this don't just ignore the 0. Don't do anything with the 0. Just leave it as is. So one thing to really make sure for your project is to label P1 and P2. So tell me what P1 and P2 are. If you don't tell me what P1 and P2 are, then you will get docked points. So make sure that you let me know P1 is proportion of males who do this. P2 is going to be proportion of females who do this. Okay? So let's go to our data. Okay, so how am I going to put this into Statcrunch? So let's go back to our data. And let's say we want to look at gender, because gender, I think I have males and females only here. And let's look at love at first sight, okay? Which is just a yes or no answer. So both of them, notice that they both have only 2 levels, 2 different options per each variable, okay? If you look at the assumptions, we do have a large enough sample, so we have 105 samples, so that's pretty large, okay? Or it has to be normal, but yeah, we have a pretty large sample. So now what we want to be able to check, or we want to be able to do is do these the 2 proportion z test, because there's 2 levels and two two levels, and then there's 2 proportions, 2 categorical variables. Okay, so the first thing to do is to set up your null and alternative. Okay, so we're gonna set my null and my alternative right now. So let's just write HO and your HA. So this is what you want to write first. P1 is equal to P2, and P1 is not equal to P2. So remember, you need to label what P1 and P2 are. So let's say P1 is going to be the proportion, of males who believe in love at first sight, okay, and P2 is going to be the proportion of females who believe I love at first sight. I'm just going to abbreviate it like that. Okay, so that's what my P1 is, and that's what my P2 is. Proportion of males who believe in love at first sight, and proportion of females who believe in love at first sight. So this is basically what we're testing. Are they equal or are they not equal to? Okay, so we tested the assumptions. Assumptions look good. Okay, now we're going to look at this guy. All right, so how are we going to do it? Now, typically what you would do, you would press on stats. Then you're going to go to proportion stats. Because we're dealing with 2 samples, we're going to write 2 samples. Now, you're not going to do with data, because if you click on with data, I know we have the data, but we don't have it in the form that Statcrunch wants it. What it wants it is in sample 1 and sample 2, which we don't have. We don't have 1 column for males, 1 column for females, and within those columns, we have whether they believe in love at first sight or not. We don't have it that way. So instead, what we're going to have to do is we're going to have to summarize it. Now, the way that we're going to do it is the following way. So before you do that, you're going to click on stat, you're going to click on tables, and you're going to go to frequency so that we can get the summarized data. So first, let's click on love, okay, because that's the variable that we're going to try to count, and let's group it by gender, okay, because that's love. Love is here. Here's love at first sight, and then gender. Here's my gender variable. We're going to press compute. And basically what's going to happen, if you see here, if you look at this table, it tells you that there's 62 total females, okay? So it counts how many females you have. And it tells you of the 62, how many don't believe in love at first sight and how many do believe in love at first sight. Here you have the males, there's 39 of them. How many of them don't believe in love at first sight? How many do believe in love at first sight? So if you look at the yeses, you can kind of see the proportions already. Okay, so this is basically your p hats. Okay, so this is what you're going to be looking at. Now, let's keep that there. And now what we're going to do, let's test it. So we're going to click on stat, go to proportion stats, click to sample, and now we're going to click with summary, not with data, because we're summarizing all the proportions. Okay, sample number 1. This is going to be your P1. Now remember, what was P1? Let's go back. Your P1 was a proportion of males, okay? So what we're going to look at is males. So males here, how many believe in love at first sight? That's going to be 21. So that's going to be 21 on the top for number of successes. Observations, we have 39 males. Okay, sample 2, P2 was my female. So I have 26 of them believe at love at first sight. And then the rest of it is going to be 62. Okay, notice here's your hypothesis test. The P1 minus P2, just leave it as is. You want a not equal to. This is what we want. No numbers. Let's press compute. Okay, so here is our p-values. Okay, so here are the null and the alternative. Here we have the counts and the totals for each of them. We have our differences, okay? And then we have our z-stat, which is basically the z-score, how far away you are from the mean. And then you have your p-value, which is basically what you want. So all of this stuff is what you want to be able to do on your project. Make sure that you tell me what population 1 was, which in this case was males, and population 2 was, which in this case was females. Okay, so that's basically what you do. You then set your alpha, tell me you reject or not, and then give me a conclusion.